intelligence in me. You don't think that. So have we changed our definition of chess? Or have we changed, or have we created an intelligent machine? So we need to, we tend to reduce the argument down to a single activity or behavior that we're thinking about.
Yeah, we get jaded to certain things too. 50 years ago, we gave someone a cell phone, like this thing recognizes my face. You know what I mean? Like they'd be like, wow, it's intelligent, but now we're just like, oh, big deal. You know? Like,
yeah. Patrick,
first, I'm forgetting your name, I'm sorry.
Oh, Matt.
Matt, and then you've been waiting, I'm forgetting your name. Brian. First Matt and then Brian.
I think the thing about computers is, like, especially Google, when you ask them something, it's right away, and it's immediate. When you ask your friend, like, they have to recall it from their own memory. And it's like Google has, like, a gigantic brain. You know, you can ask them any question, they don't have to, like, think back to memory, like, 10 years ago or 15 years ago, it'll just spit it back at you. But it can just answer that question. It can't give you, like, an analysis. Like, it can give you a book report, but not a book review. I think that's a main problem, main difference in between two.
I'll just respond to that, the idea of humans taking longer. Alan Turing, when he wrote the paper on computational intelligence in 1954, and he predicted the Turing test, which I'm going to show you. Basically, he said, if you can carry on a conversation with a computer without realizing you're talking to a computer, then that computer is intelligent. But even Alan Turing realized that this has problems, because he said, if you ask a computer what is 2,376 multiplied by 17,434, a computer can answer correctly immediately. A human can't. So if you ask a computer that question, it would have to wait for 2 minutes, then give you the wrong answer, and then you'd think it was human. So to make a computer intelligent, it would have to pretend to be stupid. And he was writing about it. He realized the problems with this back in 1954. He was writing about it. So.
Hold on, we'll put you in the queue here. And I want to come back to that point.
Well, I guess, just kind of the whole idea of teaching apes how to,
I didn't hear that, sorry.
On the topic of just teaching apes sign language tricks and calling it artificial intelligence, I would argue that it's not. It's no different than, rewarding a child for learning something. Why are we defining it as artificial when an ape does it? Is it because that we think, oh, they're only doing this for the treat? Because, I don't know, I mean, some programming now, most people work off of, past experience. If this occurred, then that happened, as a result. So if I make this sign, it means this, and because of this, I get that. And that's how most people operate. They're jaded or they're biased because of past experiences. It's not as, obvious as if I say this to this person every single time they're going to punch me in the face. It's, it's a lot more subtle. But altogether, it's the same thing. I wouldn't call it artificial intelligence. I would just call it intelligence.
Well, this is modus ponens.
It is?
Modus ponens, the Latin predicate logic.
It's also an old debate about stimulus and response. Is there any mediating agency in things that say between a stimulus and a response? Right? A lot of people say there isn't in non-human organisms, but the human organism has some other kind of agency or faculty that negotiates or arbitrates between stimulus and response. That's another way into the problem.
I guess my closing point on that was, the idea of can machine, like not wasn't think for itself, but like have its own, bias or experience on a subject rather than just producing the answer. I think it probably can if it continues to get the wrong answer, and it is, and it is to the point where there is some sort of thing that allows it to know that it is wrong, but it's unable to get the correct answer. I think it's just impossible for the machine itself to care.
Well, there are chatbots now, natural language processors that talk online that have personalities you can put into them. And so you can train them based on the speech patterns of different people, and they have those personalities, so they will behave in different ways. So this idea of giving an opinion, yes, they will. So that is available now. We have AI that does that already. So.
Richard, why don't you join in and then give a few more comments in the back?
I'm very interested in thinking about artificial intelligence in a way that I have read people are trying right now, and that is because we have now a good understanding, not a great, but a good understanding of the way the human brain is set up. And it's quite complex, and at this point it cannot be adopted fully by humans, but that is the aim and not, it would be a very limited kind of computer, especially at first, but it would give people an understanding of the process of what the brain does. And it would be attacking the problem not from the final result, but from the very beginning. And it has great appeal for me.
We'll be showing the neural network systems in.
Yeah.
And reading
not next week, the week after, we'll probably try and cover some neural network.
I will be reading a novel about
and the
neural net that goes through several implementations. So the novel that I've selected addresses this question sort of from the angle that you're posing the problem.
Okay. What book is that?
Galatea,
Richard
Richard Howard's, yeah.
Yeah, is that in the bookstore?
It is. I think, I know I ordered it, so it should be in the bookstore at the Foundries.
Okay.
Kind of bringing up Skinner and all of that. This is the same Skinner, I imagine, that has, like, he did the experiment with the birds and conditioning and everything like that, right? Like reward, response, and that sort of thing.
Mm-hmm.
I mean, we see it all the time. That's where we get things like, you know, the Skinner model can be seen in, you know,
this
training.
This is a different Skinner on the slide.
Okay.
This Skinner is different on the slide.
Because I was going to say, in that sense, like if you're, you know, isn't that basically where we get the notion of training, you know, animals to do, you know, like training apes to learn how to sign, training dogs, you know, obedience training and everything, and now we can even see it in our own lives with anybody that's, you know, plays a lot of video games, you know, Xbox Live achievements and all these other, you know, things for our phones and everything. Like I think until we can have a computer that we probably have this more and more nowadays, but until we can have a computer that can feel some sort of reward response or have some sort of stimulus of, you know, reward of learning or something, then, you know, I think that's one of the big things we need to consider in the advancements of AI is can computers not, I guess that sort of introduces a sense of imperfection, you know, the idea that a computer doesn't know something or hasn't accomplished something yet, but in accomplishing something, there's, you know, some aspect of reward or accomplishment. Would it be possible to, you know, create an artificial intelligence or being or whatever that can have that happen, can do something new and feel good or whatever about it?
You mean like teaching a computer to like have an understanding of incentives and opportunity costs? Like I could be learning this instead of this.
The answer to that is we don't know. We've not done it yet. We don't know, but there isn't a definite knowing. But I do have some media about that I will bring in. I've got some, I've got some documentary footage that talks about exactly that from a documentary series on consciousness and AI, which I'll bring in. So someone at the back who hasn't spoken yet.
Hold on, I think, I'm forgetting your name. You're Adam's been waiting.
Okay, give Adam.
Well, just from the discussion so far and what I've heard, I think we need to. I think, I don't mean to jump ahead or anything, but what is the sounder accepted definition for AI?
Oh.
Well, that's what, I think that's
This is where you say, we set up a word in that place where our ignorance begins.
That's next. That's next. We're good. The basic, most of the definitions we have are basically when it replicates, involve replicating an activity that we consider to be human.
Well, the only reason why I asked that, and just going off of your discussion on great apes, you're talking about how it's not actually artificial intelligence, it's them learning how to get a treat, basically. So it's not really intelligence, it's behavior, it's learned behavior. And you can then move on to the idea of computers doing the same thing. It's not intelligence, it's behavioral learning.
You're actually moving very nicely, segueing into what the kind of topic we will talk about next week. But I would like to move on.
Did you want to do some more? Because we're
going to run out of time. I want to introduce another concept quickly.
I'll just jump in here. I will come back to these questions too. I have a little bit to say about great apes and the acquisition of language. There's a lot more that I want to learn. And I was interested in this class because it gave me an opportunity to find ways of working out some problems I've been trying to find casual ways of talking about. So we will come back to a lot of these questions.
Oh yeah, the questions you are asking and the things you're talking about are almost in the crux of artificial intelligence. You're asking the key questions of artificial intelligence.
And just a quick footnote, if you read on that handout that I sent around today, if you look at the one that's number 480, it starts toward the bottom on the left-hand side of the page. Will to the power 480 is basically one of these incredible moments in the history of ideas when Nietzsche says, you know what, I don't think there is any such thing as reason, will, soul, intelligence, right? He says these are all ideas that are no longer of any use. They're fictions, right, that worked for us for a while, but they're not useful anymore. And then he resorts to an evolutionary understanding of human beings. He says we are just a certain species of animal. And we adapted by using these concepts like rationality and intelligence. Okay? But you know, they helped us to adapt to our environment. They helped us to reproduce, right? So you'll find in that passage a lot to think about that will help to move this discussion along, perhaps, and maybe also force us back to think about some very basic concepts that we are often kind of just assuming are in play. So with that, I'll turn it back.
Okay, I was going to quickly talk about another concept, slightly different concept, a specific concept in AI, gameplay. Since the very first artificial intelligence systems, back in 1951, one of the first computer programs ever written was to play checkers. So right from the start of computer hardware, software, people were building games. And in the middle of the 1950s, Arthur Samuel developed a more refined checkers program. And by the early 60s, these programs could play very good games. And of course, this has been continuing on until 97 when Kasparov was beaten by Deep Blue. So why would we teach computers to play games? So let's go back to this idea of the Egyptians and the god and the guy in the statue that you want to get this information. Tell you about a guy called Wolfgang von Kempelen in the 15th century, invented a chess machine. And it had a human robot that played chess. And I think it was 15th, 16th century. This was taken all over the courts of Europe. And the box was too small. He could open it open, so there was no one inside it that could fit inside it. So no one could work out how this machine played chess and won at chess. What they actually had, there was a person inside it, but the person had no legs. That's how they fit them inside. So this guy with no legs managed to fit inside and operate this machine and this chest plate machine to Europe. And people were fascinated with this. So we've had this fascination with machines that play games. We want them to play a game. From the first artificial intelligence programs, we taught them to play games. Why?
It's fun.
It's fun. Fun. Good answer. I like it. I'm a professor of computer games. I love games, but not really. It's not. That's not why they did it. They had serious reasons for doing it. Yeah.
Games require abstract thought.
Good answer. Yeah. Abstract thought. Games were seen as intelligent. This idea, I gave you the answer earlier. Everyone thought chess was an intelligent activity. Computers couldn't play chess. So if you could get a computer to play chess. What else?
Games is about decision. About decision making.
Decision making, yes. Games involve formal decision making. Basically, they have rules, and you have to make decisions in those rules. So they have a system. Yeah?
You could say that games inherently have are designed for net gain of information. So the idea, I guess, that had it in my head where I was going with this, but I think what I'm getting at is just this idea of by playing games in different scenarios and teaching computers to play games, new ways of making games and I don't know. I lost it, but
it might just be for the programmers saying in a game, especially in like checkers, the rules are very limited. So if you're going to try and, if you want to model intelligence, I guess, or you want to create a model of something that can do an intelligent function, you're going to want to limit the factors as much as you can. If you want to make something that
it's a constraint system.
There's too many things. Yeah, with a game like chess, there's the constraints are so limited. There's only so many movements that can be done that you can really focus on.
And this, whenever we talk about, my PhD's in artificial intelligence, and whenever we talk about artificial intelligence, we're not trying to create this human consciousness, we're trying to solve one particular problem at a time, little constrained systems that we're looking at. So, you've got most of them, but intelligent activity. There's a philosopher, a professor of philosophy who was at MIT called Hubert Dreyfus, who unfortunately is famous for one thing, really. In 1965, he made the statement that no computer will ever play a decent level game of chess because it is an activity that involves human creativity. And then, it was literally a few months later, he was beaten by a computer. And so in history, he's now famous for this, unfortunately. Most games have a winning state. You can actually test whether the machine you're building works or not. Because if it can beat the professor of philosophy, then it's working. You've created that. And exactly as you say, it's constrained and structured. So we can do this. So the argument has been, with games, what has happened, and I touched on this earlier, is have we created an intelligent machine, this machine you can buy from Best Buy, or a chess program you play in a web browser? Is that intelligent, or have we taken something we formerly thought was a creative abstract act and turned it, analysed it enough to break it down into a set of rules and turned it and realised that that's what the game is? And this is the question about much artificial intelligence work, that we set out to create something intelligent, and what we actually do is end up analysing the process we're trying to recreate in ourselves, and realizing that we, in some way, are more mechanistic than we previously thought. And that's been a kind of result of much artificial intelligence research. We try to model the human brain and build artificial neural networks, and what we end up doing is actually learning more about how our brains work. And that's been one of the products to come out from AI quite a lot. Any comments on that one? Go on.
Is the next level then, you know, teaching computers to operate under structured rule sets is the next level then to teach computers how to make their own structured rule sets?
I'll be showing you systems that do that, yes.
So, game designing computers?
Game designing computers. There are game designing computers. There are procedural generation systems that generate content for games. So those already exist. In fact, Alex in computer science does some research in that area. So
I know that there's things like speed tree that, you know, hey, in this virtual environment, you basically hit a button and wow, all these trees get modeled. But is there anything where like actual games, like a chess or something like that, where, you know, an actual game can be created by a computer and then, you know?
I don't think so. Probably not. Not really. Not at that level, no.
I'll circle back to some of this discussion of games from a different point of view. There's a theory of intersubjectivity that relies heavily on games. Hubert Dreyfus actually got his start as a philosopher who studied Husserl. And Husserl is one of the early phenomenologists who was really fascinated by trying to understand consciousness, the nature of consciousness. And he's associated with a certain theory that we call intentionality. And sometimes the theory of intentionality is quickly expressed as consciousness is always consciousness of something. That consciousness is always intending, right? Focusing or searching for some kind of an object that it can latch onto.
The way I always describe intentionality, and apologies to those of you who are Muslim, but eating bacon. If you eat bacon, you know what bacon is. Will the computer ever know what bacon is?
Let's hope so.
And it's to say, eat an apple. Will the computer know about eating an apple? It's that concept. That's intentionality. You know what that is.
Mm-hmm. So Dreyfus comes out of a certain tradition that sets him up for that kind of statement. Mm-hmm. A computer will never be able to defeat somebody at chess, a person in chess. There's a theory of games in that tradition that takes an odd turn, and it's more about play. It emphasizes that games are really about play and give and take, and the games aren't manipulated by any outside agency. So a game has this kind of reciprocity to it, and just imagine playing catch, right? There's no real purpose to throwing a ball back and forth, right? But all of a sudden there's this kind of reciprocity that's involved in the notion of playing a game. And then that theory of gaming extended out into the notion of conversations. That one of the things that makes us really human are when we talk to one another. And that a good conversation is like playing catch, right? Nobody's really controlling the conversation. It kind of goes where it'll go. So there's not just one person pitching and another person catching, you know, in sort of that rule-governed way in which we practice to play baseball, right? So we'll explore some of these ideas. I don't want to do it too much right now. But this is a very rich, very rich topic to explore from the perspective of hermeneutics. So if you're interested in what I'm saying, I'll just reference the people I have in mind. The book is called Truth and Method, and the author's name is Hans Georg Gadamer. Okay, great.
Mm-hmm. So, have we got? Oh, we're almost out of time. I did have an activity for you. Well, I did have an activity to do, but we're not going to have time to do it. We'll do it next time. We'll comment. We'll probably finish it there. We will put some of this up on. We'll put these things up on Canvas. Next week we'll be starting some of the graduate reading. Patrick and I will meet next week. week to talk about that and decide what the first thing you'll be starting reading. We'll try and, on Tuesday, we will look at, I think, the definitions. So definitions like machine intelligence, artificial consciousness, artificial intelligence, what these definitions actually mean. Okay, and what we think they mean and what other people think they mean.
We have 5 minutes?
You have 5 minutes.
So, did anybody else want to return us to something that didn't get addressed? We'd allow you to take your hands up a while back. If not, I'll just say maybe a quick word. A lot of times we think of language and speech as coming from within ourselves. And when we think of language and speech in that way, we're suffering from a great forgetfulness because we were all infants at some point in our lives, early on, right? And we had to acquire language. So language is something other, right? Language is, let me just quickly explore this in a way that I normally wouldn't say this, but language is like a tool that gets internalized. Right? It's not something we arrive with. It's not already in us. Right? We have to acquire language. Now, if you think about that idea long enough, and if you puzzle through some of the problems that we're surfacing in the conversation earlier this evening, there's going to be a way in which this kind of problem is going to surface for you. Is language a tool? Well, if it's a tool that's intentionally, consciously, and self-consciously created, then we might imagine ourselves thinking that consciousness and self-consciousness precede language. They're somehow necessarily anterior to language. One of the most difficult words to talk about in this conversation is what we mean by prior, or something that precedes something. So I'll circle back to that, because Aristotle had some beautiful, beautiful things to say about priority. Okay? But we often, in our way of speaking, think about language as a tool that we somehow invent or create, okay? And it's somehow part of us, and it gets externalized and perfected. But if you think about ourselves, if we think about ourselves as infants who acquire language, and if we think about language as something other, right? Then this thing, language, has to be acquired and appropriated. And in that way, we might imagine ourselves saying, you know, consciousness does not precede language, but language precedes consciousness. Right? With the acquisition of
say that again, Patrick.
Okay?
Lost me with that.
It's a gross generalization, but it'll help you to get your mind around some complex questions. Okay? We often think that language is a product, right? It's something that follows upon our having consciousness and self-consciousness. It's a tool we invent, okay? So language is the invention of a certain kind of rationality that's non-linguistic, so to speak. Okay, that's a problem. But if we think about how we acquire language, let's think about that for a second to help make it clearer, right? Then actually, consciousness and self-consciousness are something that follows upon our acquisition of language, not the other way around. Language, right, precedes consciousness. Consciousness does not precede language.
But this is interesting because AI researchers often argue with philosophers over these exact points.